So the sine rule we looked at the end of last term. It is on your formula sheet. A on sine A equals B on sine B equals C on sine C. The triple rule here just lets us know that we can use any of the pairs. Remember, in your triangle, the capital A is the angle and the lowercase a is the side opposite that angle. Alright, so you must remember that every side and angle is going to be in pairs. You only need two pairs to do the question. The things we remember to look out for, you need to invert the equations when looking for an angle. What do I mean by invert the equations?
Swap them.
Swap them. Okay, so that sine A will be on top and the A on the bottom. Aaron. And you need to take care with obtuse angles. What was the problem with obtuse angles? When we're using the sine rule,
Swap them.
subtract to form 180 because the calculator will always assume you want the acute angle. So if it gives you an angle like this big and it says the answer is 15, clearly that's wrong. You need to know to do 180 minus it to find the obtuse angle. They're the things we need to watch out for. We're going to look at a couple of quick examples. In this first one, we have a lowercase r here with the 35 degrees. But when we get to the 70, there is nothing in the angle opposite it. How are we going to solve that problem? Okay, there's nothing in the pair that I need.
Do 180 minus 35 plus 67.
That's correct. I know that the angle sum of a triangle is 180, so if I do 180 and I subtract 35 and 67, what do I get? 180 minus 35 and 67. And we get that that angle must be 78 degrees. So I have a 78 in here. So you may need to do that to make sure you have your two pairs because they must be opposite each other. Once I have those, I'm going to put them in my rule. Do I want the lowercase a or the capital A on the top? The lowercase because it's a side I'm looking for. Now I'm going to put the R with the 35. So I've got R over sine 35. The other pair is the 78 and the 70. The 78 is the side, so it goes on the top. And the 78 here is the degrees. To solve that equation, I am simply going to multiply the sine 35 to the other side of the equation. So that R is 70 times sine 35 on sine 78, sorry, saying the wrong words. So I grab a calculator, I'm going to put that in. On the top is 70 sine 35, and on the denominator is sine 78. It doesn't like that I didn't put the brackets in because it's fussy. It probably doesn't like that I forgot the multiplication there as well. Now it'll be happy. Okay, so I get the answer as 41.047. I didn't specify in the question how accurate to answer that. Please check every single time you're rounding. It is very frustrating to take marks off in Year 12 for a rounding error. Okay, that should not be happening. You need to check what the question is. So for this one, I'm going to go with 2 decimal places. So to 2 decimal places, that would be 41.05 millimetres. Alright, so always check that rounding for every single question. If the question does not specify, you choose your own rounding. Okay, this question here, I need to find my pairs as my first step. So I've got this angle here, the side opposite is this one, so that pair works all right.
Sorry, so the last question, that R was what we were trying to find?
Yeah, the missing side here was the R.
That was the...
Yeah, looking for the side.
All right.
So this question here is a bit different because I'm looking for the theta this time. It's an angle that's missing. So that's my first pair. My other pair I'm interested in is this 9 and the 15 here. So my pairs work up really nicely. Don't need to do any mucking around with them. Because I'm looking for an angle, I'm going to make sure that the angle is on top of the fraction. Remember, if you accidentally do it the wrong way round, your first step is to flip it, so it's no drama if you do an extra step. It's just easier if we put it in there to begin with. So I'm going to use the theta and the 20, and so I'm going to get sine theta over 20, and then I've got sine 15 over 9. So the first step in this equation is to get rid of the over 20. So I'm going to times 20 to the other side. That's going to give me sine theta is 20 sine 15 over 9. So on my calculator I can just type that in. 20 times sine 15, and the denominator is just a 9. And that gives me the answer of 0.575. That is not what theta equals. That is what sine theta is. You need to make sure that you get theta on its own. How do we get theta on its own when there's a sign in front? We can't divide by sign, it's not a number. We use the inverse sign, which is on your calculator is above the sign. So you're going to have to press shift and then sign to get the inverse sign, which has got a little -1 on it, remember? Okay, so theta is the inverse sign of this. Now in the test, I don't care if you write that down, as long as you know what you're doing. You do not have to write that you find the inverse there. You can just put it on the calculator, that's okay, but you need to make sure you know what you're doing. So you find the inverse sign of that previous answer. I didn't bother writing it down because I'm just going to use my answer button. And I've got 35.11. Now with angles, you need to be very careful whether the rounding is asking for decimal places or degrees, minutes, seconds. Right? So make sure you've checked that. We're going to answer this one to the nearest minute. So I need to press the degrees, minutes, second button, which is the one with the little bubbles and things on it. So I've got 35 degrees, 6 minutes and 37 seconds. To the nearest minute, that would be 7 minutes because 37 is more than 30. So remember, you round up at the 30 rather than a 5. So it's 35 degrees and 7 minutes. Everyone familiar with the degrees, minutes, second button? We remember that? Excellent. All right, one last example. So for this one, I've got this pair here, the 14 goes with 106. Okay, and then when I look at the 9 here, there is nothing opposite it. Okay? But at this point, there's nothing opposite. I can't find that angle using angle sum of a triangle because I don't know this angle. So what I'm going to do is I'm going to call it another letter. Let's call it alpha because we know that we like Greek letters for angles. So it looks like a fish, yes. It's the Greek letter alpha. So we're going to find this angle. Once we've found that angle, then we're going to have to find this angle by using the angle sum of a triangle. Does that make sense? Okay, so our pair doesn't work to find this because I don't know this side. I can't use that as a pair. So I must use this pair instead, find my answer, and then change it. Okay, so I'm looking for an angle, so the angle is going to go on top. So on top I'm going to put sine alpha, and that's going to be on top of 9. Over here I've got sine 106 over 14. First step, same as last time, remove the denominator of 9. So sine alpha, why does it do that? It's 9 sine 106 on 14. And the calculator will tell us over 14. I've got 0.617. Need to make sure you inverse sign that answer. and I've got 38 degrees. Just leave it to the nearest degree for this question. So that's 38 degrees. I have not finished the question because I found this angle up here is 38. That doesn't tell me the theta that I was actually looking for. So all I'm going to do is angle sum of a triangle. So I'm simply going to do 180 minus the 106 I already had, minus the 38 you just calculated, and what are you left with? Pardon? Is that correct? Did you just make that up?
No, I was trying in my head, but I'm
Incorrect.
not close. Oh.
So close. 36. So is everyone happy with how to cope with a triangle if you don't have the correct pairs? Alright, so here I didn't have the pairs working for the angle, but I solved it at the end with angle sum of a triangle. And here, where's the other one? Here I didn't have the pairs working at the beginning, so I used angle sum of a triangle at the beginning. Okay? So the only other thing you've got to look out for is if you get an acute answer when it should be obtuse, and simply do 180 minus it. We ready to try it ourselves? Alright, let's go.
Is this 504?